Okay, so Workplace and Apprenticeship Math 30, Chapter 7. This is Part 1 for 7.1. And we're talking about trigonometry. Now, you should know already that trigonometry has to do with sine, cosine, and tangent. Okay? So you should know that already. 7.1 is talking about something called the Sine Law. Now, we are not necessarily just working with the sine and the cos and the tan separately to solve just for one side of a right triangle anymore. We're kind of stepping it up now. And we're actually going to be moving to triangles that are not right triangles. So there's a lot of trigonometry that's related to triangles that are not right triangles as well. But first of all, if I could get everyone's attention up here. Okay, thanks. Save the doodling for later. Thank you. So the sine law. We're going to start with reviewing what the trig ratios are. You remember SOHCAHTOA? Look at this. S for sine, O for opposite side, H for hypotenuse. That's the SO part, right? So, and then the cosine is the C over and equals A over H. So ka, and then TOA, T is O over A. Question?
Can we turn off the lights? It's kind of hard for me.
You can turn off the light there if you want.
Okay.
It's shining on the screen too much. Okay. So if we were talking about angle B, let's say, angle B, the angles always go with these trig functions, right? Yeah, sure. That one okay?
Yeah.
Both of them? Shut off all the lights? Is it party time? What is this?
Yeah.
Party time.
Got a dance going? No? Okay, we can't do that.
No, put it back. Put it back. Okay.
It's good, it's good, it's good. It's good. Okay, quiet. No. Okay, so this the angle. The angle goes with the trig function. So watch this. Sine, guys, of B, so it's angle B, equals what? It would be what over what? Equals the opposite side, which is little b, over the hypotenuse, which is
Little c.
little c. All right, so back to trig. Cosine, right? Adjacent over hypotenuse. So let's do cosine of A. Oh, what's the cosine of A, angle A? It is the adjacent side. Which is the adjacent side here then? B, yeah. So it would be B over, and what's the hypotenuse? We said it was C. Oh my goodness, look at this. Sine of B is the same as cos of A. Isn't that great?
Wow.
That's like amazing. Is that amazing?
No.
No, the answer is yes.
Oh,
it is
that's
amazing.
right.
Okay, so tan of, let's do, well, we can't do C really. We can't do tan of C. We don't really include the 90 degree in there. Do you know why? Do you know why we don't really use the 90 degree? Well, here's the thing. We can't really refer to these trig functions with the right angle because the opposite and the hypotenuse are the exact same. Is that a problem? Could be.
What are we trying to find?
Sine of 90 is 1, and cos of 90 is 0, and tan of 90 is undefined. It's undefined. So we're not going to use the 90s. We're just going to refer to these other two angles in a right triangle. Okay? So tan of, let's say, A is going to be opposite side, which is little a, over adjacent side to A, which is B. Okay? So that's a review. You should know that. And any questions? Looking around the room, seeing none. Let's move on. Okay? Example, with right angles. This is super easy. I think you guys could probably do this with your eyes closed as you dream tonight, which might be actually a nightmare for you if you dreamt about math, but they're dreams for me. Maybe nightmares for you. Anyways, this is baby stuff, I think, right? Like this is literally, no? Yes? Okay. Without looking at the solution here, let's take a look at B. Let's find the value of x. So this is the angle. This is a tough one. I'm given this side, which according to this angle is which side? The opposite, the adjacent, or the hypotenuse? This is adjacent. Very good. And I'm also given the value of this side, which is what? The hypotenuse. Very good. See? Little baby stuff. That's a little baby stuff. And so which trig function should I use to try and solve for x here? Which one includes adjacent and hypotenuse? A, H. So, TOA. So cosine. Thank you. So watch this. The cosine of x equals the adjacent, 15.2, divided by the hypotenuse, which is 17.8. Now, here's a big problem, huge problem. How do I solve for x here? Anyone remember? Sorry?
Second function.
Second function. Yes. Well, this is a hilarious lesson. Second function. So let's get into our calculator here and we'll clear that. So notice above the trig functions there. So I've got cos. So you're absolutely correct. I'm going to do second function cos because really, look at this. That's what undoes the cos. Cos to the negative 1 undoes the cos. And what I do to one side, I have to do to the other side. So in order to solve for x, well, let me just write that down. Solve for x, we do second function cos, and then we just simply plug in 15.2 divided by 17.8.
31.
So you get 31.357 or 358? 31 point, let's say 31.4. 31.4. Now what are the units there? I have to have units if I can. I got to figure out what are the units. This is an angle, so it's going to be degrees. Very good. Okay, so x should be 31.4 degrees. Let's see what the solution says. Look at that. They've done the exact same thing as we did. They've rounded to the nearest degree, which is fine as well. If you have one decimal place, even better. Okay? All right. So let's do one question from the Build Your Skills. I'll get you started with one question. So this one says, calculate the length of each indicated side. So I need to know x. Well, I'm given 28 degrees. I'm trying to find the opposite side, and I'm given the, well, this is the side that's opposite the 90. It's the largest side, so that is the hype side. Hypotenuse.
That's hype.
The hippopotamus. Hey? Don't believe all the hype. That was a joke. All right. So which trig function should I use to connect these three? This angle, the opposite, and the hypotenuse. So, right, sine. Very, very good. So excited. I'm so excited. So I'm going to put sine of 28. Remember, you need to have the degree with the trig function there. It's either going to be x if you don't know it, or the angle. So sine of 28 equals the opposite side, which is x. We don't know that. It's unknown, over the hypotenuse, which is 9.4. Okay? So with this set up like this, now we can do a solve for x. And this one is really easy. I can multiply both sides by 9.4. So in effect, really, I'm cross-multiplying. You can always cross-multiply across the equal sign. So that 9.4 can multiply by sine 28. So I got 9.4 times sine 28 degrees equals, and x is left over there. You see how that 9.4 comes up over here? See that? It's gone. So, did anybody do that on their calculator yet? Make sure your calculator is in degrees, so you'll have different different states. It could be degree or radians or gradians. So make sure it's in degrees, D or DEG, which mine is. See, degree, not radian, but degree. And then we'll do 9.4 times sine 28. And that equals 4.4. So x equals 4.4. Now, is that reasonable? Well, hypotenuse is 9.4. This is going to be shorter. 4.4, that's pretty reasonable. Okay? That looks pretty reasonable. So there you go. There's Build Your Skills number 1. And the rest will be up to you. Now, looking ahead, okay, there's some more questions. Again, this is just right angle stuff. Okay, what I want to get into today, and there's some practice with the right angle stuff that you should already know about. But what I want to get into today is this new lesson on the sine law. So, let's take a look at this. And this is on your page 260 in front of you. Okay. All right, what is the sine law? Well, the sine law says this: using trig ratios, sine, cos, tan, as well as the Pythagorean theorem. Do you remember what that is? A squared plus b squared equals c squared. Okay. So using those, we can come up with a new law called the sine law. And now it uses the sine, the trig function, the sine, but it's a little bit different. And this applies to non-right triangles. So a new term for you, oblique triangle, is a triangle without a right angle. Okay, that's what oblique means. Oblique triangle, a triangle with no angle equal to 90. So this would be an oblique triangle. And what's another name for this type of triangle? Does anyone remember?
That is an isosceles.
Not isosceles.
Scalene.
Close. Scalene, yep. There's still yet another one.
Obtuse.
Yes, obtuse. Okay, so if an angle is greater than 90, great, it's obtuse. Look at this angle, this triangle. This triangle right here, all of these angles are less than 90. What's this one called? Let's say that they're isosceles. No, I'm talking about the angles. If all of the angles are less than 90, that's called an
Cute.
It's a cute little angle. And this is obtuse. Now, both of these would be oblique because there's no right angle there in these ones, okay? And even this looks like a right angle, it's not. Okay. Good with that? Okay. Now watch this. This is really cool. I'm not going to get into why this is so much, but I'm just going to straight out show you what the sine law is. The sine law relates, okay, an angle of a triangle with its opposite side. You see how this is capital B, the angle, and then the lowercase b is the opposite side always. It's the same for all. Here's uppercase C for the angle. The opposite side is little c. Okay? And finally, uppercase A, that's the angle. The opposite side is little a. Now, there exists a special relationship between the angles of a triangle and their opposite sides, as well as with another angle in the same triangle and its opposite side. And that is called the sine law. So notice this. If you were to make a ratio of the sine of angle A divided by the side length of A, its opposite side, that ratio, this value, would be the exact same as if you used sine of angle B, another angle in there, divided by its opposite side. So that ratio is always going to be the same. These values don't have to be the same. A and B don't have to be the same. And A and B here don't have to be the same. But the overall ratio will be the same. And you can take any pair of an angle, sine of an angle, with its opposite side, like this, and you can set up an easy proportion. So what that means is this. If we have any angle, and hopefully there's one here, okay. So if we have any angle, we can use the sine law. Zoom in for you a bit here. Okay, so we can use the sine law to calculate unknown sides and angles. So watch this. Again, I like to do this with my diagrams. Circle the angle and its opposite side, because those are going to go together in this ratio. And sometimes, usually you put the sine of the angle on top and the on bottom, but it can be flipped. And I'll show you that in a second. But according to what we just saw, sine of angle 52, oh my goodness, 52 degrees, divided by its opposite side length, 16.8, watch this, very, very carefully, this is the whole point here, is equal to any other angle and side combination in the triangle like this. So that's going to be also equal to, and you put the sine on top again, always the sine's on top, sine has to be on top, over unknown value A. Now, this uses the sine law, and all of a sudden we have an equation with only one missing value. See that? And that's really good, because now we can solve for that. If you have one missing piece of any equation, you can always solve for it. No problem. So we'll do some cross multiplying and dividing. I think you guys like kind of thinking about it that way. So the A will go up there. This will go up here and multiply up here. Okay? Which that'll give us this. A times sine 52 equals 16.8 times sine 72. Okay? And then we'll also divide. This really will go down here now. See, we divide by sine 52. Sine 52. So we have A equals 16.8 times sine 72 degrees divided by sine 52 degrees. Do you guys think you can do this? You guys remember doing this? Solving like this for a simple proportion? Okay, so again, remember the values can go across the equal sign and divide, or if it goes down, that's like dividing on that side. So they can always travel like this across the equal sign, no problem. Okay, you like that? Is that going to help you remember that? Okay. All right, so figure that out in your calculator, right there. What is that?
Oh, my ears just gone.
Thank you for that bit of information. Okay, well here's the answer down below. It should be 20.3. We have one winner over there. Okay, so try that again. I don't know what you guys did. Try it again. I tell you what, this is a good way to not mess up. Okay, do 16.8 times sine of 72 and then hit equals. Just do that first, and then go divide it. Take that little answer, divide that now by 52 equals. If you do it in, do the top equals and then divide it by the whatever's on the bottom equals. Should help.
I'm still getting 202.
Right, we seem to be on the same page with that question, that example now. So let's take a look at Build Your Skills question number 3. Okay, so the sine law is really easy. It's just a proportion. We can take any two pairs of angle sides and make them equal to each other and then solve. So let's see if we can figure out the value of z here. Okay, so look at what I have. I have this side length and this angle. Okay, that's a pair. And I can use this one, this angle and this side length as another pair. See that? So that's what I'm going to do. I'm going to do that. So let's see. I'm going to go sine. Well, yeah, let's do that. Sine of 132 divided by its opposite side. Well, that's a big number. No problem. Equals. Now, do I put z on top or do I put sine of 15 on top? What do I do?
What do you want to put sine of 15?
I would want to put the sine of 15 on top. Absolutely. Very good. And then the opposite side over here is z. That's unknown, right? Z. Okay, this is exactly the same as the one we just did, and I'm going to show you even more of a shortcut here. So the z is going to go on top, this is going to go on top, and this is going to go down on the bottom. So you can go right to this if you think you can do this. You can go z now is on top. That equals 1794.3 times sine of 15 divided by, this is coming down here, so it's divided by sine 132. Okay, do you guys think you can do that all in one step? Like that? From bottom across the equal sign to the top, top across the equal sign down to the bottom. It's just cross multiplying and dividing. Absolutely. That's what it is. So if you can do that all in one step, just go right ahead. And then we'll evaluate that. So let's get some more practice real quick. So we'll turn our calculator on. 1794.3 times sine of 15, and I'm going to hit enter. Okay, I'm going to use that number, and I'm going to divide that by sine of 132. Should be 624.9. 624.5.
24.5.
0.5?
0.5.
What?
0.5.
No, 0.9.
0.5.
Not 0.5, sorry.
Look.
You are wrong. You're wrong.
Isaac, look.
There's right, and then there's you. You're wrong. Okay?
Look, Isaac.
So I think this should be the right answer for number 3. I think a couple of us got that, so that's good. The rest of you can just keep doing that over and over until you get this answer. Okay? That's right. Now, I'll let you do these ones on your own in a bit. I want to do one more example with you in this lesson, and then I'll let you go. Okay? And this is it for this lesson. But the one example is here now, solving for an angle. And we know how to solve for angles with trig functions. It's the second function, right? So this is not a problem. So let's do, I'll let you take a look at this example if you want, but I'm going to skip right to number 4 and do this Build Your Skills question for you, okay, or with you. So, Build Your Skills number 4 says this: calculate the measure of the indicated side or angle. So let's do an angle one. So here we go. We need A. Sine law. Hey, sine law is easy. We can use angles and their opposite sides as partners. So I'm going to put sine of 121 over 77.5. That's going to be my one ratio I'm going to use. And check this out. This is just deathly easy. You guys should be thanking me for making you do such easy things, so many easy things. And I've got sine of A, because I don't know A, right? That's the unknown, sine of A, over, or divided by, 45.1. We're going to cross multiply again. And that's going to get us this. And I'll show the steps here. So this 45 is going to go up across the equal sign and going to multiply up here, right? So I'm going to have 45.1 times sine of 121 divided by 77.5. Everyone good with that? And now to get a by itself, you guys remember how to do this from one of those first examples. Second function. So I do this. On my calculator, I'm doing second function of this right here. Okay? And that will equal a. So, okay. Well, let's figure out what that actually is first. So I'll do 45.1 times sine of 121 divided by 77.5. Okay, good. That should be a number less than 1. It should be a decimal. So 0.49. No, if you have, if you're taking if a sine value, this is just an aside, but if the ratio, if the value of sine of some angle is equal to something greater than 1, that's a problem. Because sine of any angle between 0 and 90 will be less than 1, always. It'll be between 0 and 1. Between. So if you're taking the second function here, this should be a decimal between 0 and 1. Or else your calculator is going to say, error.
Oh, so it's not possible.
It's not possible to find an angle if you have a sine value more than 1. Really. So then you won't be able to do that. Where was I? Okay, watch this. Second function, sine. Be calculator smart here now. Be calculator smart. Use your answer function so you don't have to type in that whole thing. Answer. Every one of you has that on your scientific calculator. Second function, sine of the answer should give you 29.9, which that's going to go to 30.
29.3.
Degree. No.
Are you serious? I am serious.
I got
Look.
29.3 too. What?
I got 29.3.
Did you use all of the decimals though?
I got 29.9.
Hey,
No.
one second, let me.
You did not.
Hold up.
Yes.
If you use all of the decimals, you will get this.
I got
Correct?
29.9.
It shouldn't matter.
Yeah.
It should matter
It
because
should
you just
matter.
We got the right answer.
down
That's right.
No.
So if you change the whole answer.
No.
Oh, yeah, I
Guys.
think, haha, just kidding. I got
You-
28.
you got it now?
Haha,
Okay, good.
sorry.
Me too. I just add.
I just did that.
You guys are hilarious.
Hilarious.
Okay. So there we go.
6.
Class, build your skills up to number 4 for chapter 7.1. Okay, there's 1. And we've got 2 here on this page. 2D there. And we've got 3, which we started. And then, of course, we've got another example. And then 4 is what we just started here now. So I'm just kind of showing this. And we'll start here for a second
So you want
part
to
there.
finish